let's continue with section 6.4. Remember yesterday we did transformations of exponential functions, and today we'll start with logarithmic functions, and then we'll do a little writing transformations. So you can transform graphs of logarithmic functions like previous functions, even just like yesterday. So let f of x equal the common log of x, or remember, that could also be seen as log to the base 10 of x. All right. So, and again, we're going to kind of do the same thing here. X minus h when it's attached to the x. Again, if it's negative, we're going to go in the opposite direction. So we'll go 4 right. This would go 7 left. Vertical, again, just like the other time, it's on the outside, inside x, outside y. I keep saying that. So on this one here, it follows the sign. So plus 3 would make it go up. Minus 1 would make it go down. A reflection, remember, if it's on the inside, if it's attached to the x, like it is there, it's going to be a reflection over the y-axis. If it's on the outside, it's going to be a reflection over the x-axis. Horizontal stretch or shrink, again, I keep saying this. Here, it's 4x. So we know we're going to flip it. So 4 becomes 1/4, and that will be a shrink. And log of 1/3, again, we're going to flip it. It'll become 3. It becomes a stretch. When it's a vertical stretch or shrink, it's on the outside. So it's a times f of x. And on that one there, again, it's just going to be the same. So if it's 5 log x, you're going to stretch it by 5. If it's 2/3, it's going to shrink because, again, 2/3 is between 0 and 1. All right, so let's look at a couple of examples here. So A, just example 4, describe the transformation of f represented by g, then graph each function. So f of x is equal to the common log of x, and g of x is equal to the common log of x times negative 1/4 x. Excuse me, not just x, it's negative 1/4 x. So again, look at what you're going to do here. So if we go up here, that negative is now in the inside. So what should that tell you? That should tell you that we're going to have a reflection over y. So we're going to have a reflection over the y-axis. And then, again, we're going to look at that 1/4 there. Again, it's attached to the x. So what do we know we're going to do there? We're going to have a horizontal. Remember, I'm going to flip it over, so it's going to become big. So it's going to be a horizontal stretch. By a factor of 4. Okay, so if we remember with the on this one here, we have no k or anything like that. So on this one here, it's going to still be at the origin. So remember, on that one there, we had a one there that would be 1 and 0. And I'm going to go, actually, let's go ahead and change that because I went by 4s. So I went, this was 8. And this here was 12, and that was 16. All right, so again, I would do the same over here. So that would be 4 right there. That would be negative 4, that would be negative 8. And then that would be negative 12, and that would be negative 16 there. So I just did it because of the horizontal stretch. You'll see, again, remember I said you could just graph it and then trace it to find some points if you wanted to in Desmos or whichever calculator you want. But remember, it's going to be 1 and 4 here, okay? And then since it's a common log, when we're at 1, so I went actually up, I I went 1/2, there's 1 and there's 2. So I went that way. Okay, so then that would make this be -1, and this here would be -2. So I changed the graph just a little bit. So we know that if it was at 10 and 1, so I would have my x is equal to 10. So that would be there, and it would be 1. So I would have one that would look like this. And that's just our common log one that we have done before. Okay, so now we're going to do our other one here. Now, the easiest way to see it is, let's see, what did I do there? My 1 and 0, when I reflect that, okay, it's going to become -1 and 0. So remember, it said to do the reflection. And then if I take the 4, okay, remember it's 1/4, so that means I'm flipping it, and I'll have my factor 4. So if you think about that, I have -1 and 0, and that'll go to -4 and 0. And that's kind of why I did that one there. So again, when x is equal to -4 and 0. So that would be that one right there. Again, this one over here, now remember I had one here. This one here I told you was at 10 and 1. And just think about it. On this one here, it would be over here in this direction. Okay, we know it would be 40 and 1, -40 and 1. So we know it's because it's stretching away from the y-axis. Well, as you can see, I don't have enough there for 40 and 1. So I'm just going to go ahead and draw it quicker. And again, my y-axis this time is my asymptote. All right, so this here would be my g of x. And remember, this one here was my f. Okay, so again, if you're unsure, put them in your calculator and graph it that way. The second one is b, is f of x is equal to log to the base 1/3 of x, and g of x is equal to 3 log to the 1/3 of x minus 2. So let's just kind of think about what we're going to be doing here. All right. So first of all, we have that in there. So what do we know we're going to do? We know we're going to go to right. Okay. Because again, that's in parentheses. So we're going to do that first. And then we have this out here. And then we're going to do, so that would be outside. So it would be like a vertical stretch. So we're going to have a vertical stretch. Of a factor of 3. So, or of 3. I'll take that. All right. So, again, if you think about it now, remember, it's going to be our, not our x-axis that we're going to have our asymptote on. And we discussed that earlier. When it's log, it's like the inverse. So we know it's going to be our, it's going to be an asymptote with the x-axis. So we know it's going to be a vertical line, right? And then remember our regular one, again, if we think about it, it's going to be here at 1 and 0. And then we're going to be at 1, 2, 3, and -1. And up here it would have been 1 and 3. So again, we're going to have our f look like this one. Okay. And just like yesterday, it's going to have you choose the right graph. So you should be able to do that. So that's going to be our f there. And let's see our g. So now, how can I find my points for G? So, well, we know it's going to be a vertical stretch of 3. So we know that this one right here is going to go 1, 2, 3. So we know we have that point there. So now, how can I find another point? All right. Well, to find another point, again, I'm showing you just in case, sometimes you're not going to be able to use your calculator on this. With me, it's okay, but if you're in pre-calculus or sometimes people let you use your calculator, sometimes they don't. So what you need to do is to find another point here, use the inverse. All right. So if I take y is equal to log to the 1/3 of x, then we know that, again, this base, so 1/3 raised to this power is equal to x. All right. So again, that's where I got my 3 and -1. Okay. If I take the other one, I'll have y is equal to 3 log to the 1/3 of x minus 2. Okay. Again, this base raised to this power. And so I'm going to say x over 3 is equal to log to the 1/3 of y minus 2. All right. So remember, I switched to find the inverse. I switched the x and the y. For the first one, it was just the um, definition. For this one here, we're going to kind of do the same thing. So now I'll have this base, so 1/3. So let me go over here. 1/3 raised to the x over 3 plus 2 is equal to y. So now again, choose a number on this one here. What is going to make this right here be nice? All right. So if I think about it, I can let x equal -3, because -3 divided by 3 is -1, right? 1/3 raised to the -1 is equal to 3. And then I still have that plus 2. So that will equal 5. So if we think about that here, I'm going to go -3. I'm going to go -1, -2, -3. And then I'm going to go, let's see here, 3. So again, I'm going over 1, 2, 3, 4, 5, and then I'm going to go down 1, 2, 3, because remember they're switched, and there is my graph for G. Okay, again, on these ones, really, if you don't understand it, look at the examples in the textbook and just graph it. All right. So let's go to the ones that you can do, which is writing transformations of graphs of functions. So again, let the graph of G be a reflection in the x-axis. So in the x-axis. So that's the first thing they want us to do. So we have f of x is equal to 3 raised to the x power. All right. When it's in the x-axis, when the reflection is in the x-axis, remember we can write h of x is equal to negative f of x, which in this case would just be -3 raised to the x power. Okay, and then they're saying it's followed by translation 2 units left. So remember that would be g of x is equal to h, and again it's to the left, so we're going to say it's x plus 2. All right. Well, what's that stating is wherever we see x in our h of x, we're going to replace it with x plus 2. And that's your answer for that one right there. Let's do one more here. Let the graph of G be a translation 1 unit down, followed by a vertical stretch by a factor of 5 of the graph of f of x is equal to the log to the 1/6 base of 1/6 of x. Write a rule for G. So again, you have to go in the order that they're asking you to do it. So they're saying do this 1 unit down. So if I take that, remember my f of x is equal to log to the base of 1/6 of x. First thing it's asking us to do is go 1 unit down. So remember that is going to be h of x is equal to f of x. Remember inside x, outside y. So we're going to say it's minus 1. So then we're just going to write that as log to the base 1/6 minus 1. Then it's asking us to take our g of x, which will be a vertical stretch, right? So a vertical stretch is on the outside. So that means we're taking our h of x and we're going to multiply it by 5. So we're going to have 5 times h of x. All right. Well, we just said our h of x was log to the 1/6 of x. I forgot the x there. And to simplify that one again, remember if I distribute that 5 through, I can't attach it to the x, but I can write it as 5 log to the base of 1/6 of x minus, and again, I'll distribute it to that negative. So that will give us negative 5. So again, the last two are more simple than the first ones. The first ones, again, once you, after you keep doing these a while, and I wish we could graph them more, but with the Big Ideas platform, they want you to recognize them. So the easiest thing would be to plug it in your calculator. But these you can write down and figure out. That's it. Thank you.